talk about what's going to happen the next 2 weeks.
Yes.
Okay? Because the third week is really just exams. Okay, so we are doing our last little part of Unit 2. It is a rational mini unit. So we have 8 days of rational expressions. So for today we're going to simplify, tomorrow we're going to multiply and divide, then we're going to kind of have a let's make sure I know what I'm doing day, and then we're going to add and subtract for 2 days, and then we're going to solve, have a review, and have your last regular assessment. Okay, so this will be a little, probably slightly larger than a quiz, not as big as a test, assessment here. And then we have 3 days in class to work on and ask questions about the review, which I did post. Did any of you guys work on it over the break? 1. Is that truthful? I'm really proud of you. Good job. All right. So I know there was a lot of final preparation in my household over the break. Now, it wasn't with happiness and joy that we did it, but we did do it. So, yeah. All right, and so then we have exams. All right, now, good news about exams.
They count as your lowest test grade.
It can replace your lowest test grade. Correct. Okay, so what we'll do is once I sign exemptions, those of you that are taking my final will let me know exactly what you want it to replace. You will tell me, so I don't have to go through and hunt.
What if it's worse?
Okay.
What if it's worse than
If it is worse, I will not replace it. Okay? It's not a double jeopardy kind of thing.
How many test grades do we have?
We have 3 test grades. Okay? So any questions about what's coming up? Okay. What we're doing here at the end is not terribly difficult if you pay attention every day. Okay? If you check out for the next 3 days and come back Friday because you're like, oh no, quiz next week, it's not going to be good.
So check in now.
So check in now and every day, and then you're good. All right. So today we're going to start with a fairly simple topic when it comes to rational expressions. It is just simplifying rational expressions. And this shouldn't be hard for you guys because most of you are fairly good at factoring when you need to. Okay, so these are today's notes. Okay. We're just going to do, we have 7 examples to do today, and then you'll have the remainder of your class time in which to work on your homework. Today's homework is Rational Worksheet, Day 1. All right, example 1. So if you have the expression 18x to the 6th over 27x to the 4th, we can simplify this expression. Now, to simplify expression, we must have everything written in terms of multiplication. And right now it is. We've got 18 times x to the 6th over 27 times x to the 4th. Everything is written as multiplication. So we're going to get to some where we would have to factor first so that we have it written as a product. But right now we're good. So once we have it written as a product, we can cancel. Now, way back when, you would break 18 down into like 2 times 9. And you would break 27 down to 3 times 9.
When they cancel.
And x to the 6th could be written as x to the 4th times x squared over x to the 4th. Now, if we wrote it like this, you can clearly see what cancels. You can see that this 9 cancels out with not that 9. 9 goes into 9 one time. And multiplying by 1 is the easy for me to say. Let me try again. 1 is the multiplicative identity, which means if you multiply by 1, it doesn't change the identity. It stays the same. All right, now, and we can also see that the 4's the x to the fourth cancel. And so we're left with a 2 and an x squared in our numerator, and we're left with a 3 in our denominator. Now, we've been doing this a while, so we don't really need to break this up. We could go straight to this. Okay? So, we could look at this problem and say, all right, I know 9 divides into 18 and into 27. And I would say 9 goes into 18 2 times, 9 goes into 27 3. And then here I have 4 x's. They cancel with 4 and leaves 2. So it leaves me with 2x squared over 3. So this is really where we are now. We understand properties of exponents. We know how to reduce things. So you're welcome to do it just like this green one. And you don't really have to break it up. And so this is our simplified expression. Okay? So we're going to do a couple examples like this. And then we'll move on to the kind where you have to factor a little bit. So 3x squared over 12x. So when we look at a rational expression and we want to simplify it, we look at our numerator and denominator. Is there a common factor for 3 and 12? 3. Okay? So we would say, well, I know where the, okay, don't laugh. I know where the 4 came from. Because 3 goes into 3 one time, and 3 goes into 12 4 times. Yes.
I'm right.
All right. And then we have an x squared over x. So x squared really means x times x. So that's why we can say one of these cancels with one of those. So our simplified expression is 1 times x, which is just x, over 4. Any questions about example 2? All right. So example 3. This is the last one that is like this. This one doesn't have a lot of application in terms of where we're going with it in rational functions. You don't see things like this. You might see something like this on the SAT, ACT to make sure you understand how to simplify. So I do want to go ahead and give you one like this. So it's not difficult. We just have more letters. It's the same process. We just do it more times. So we have 16a squared, b to the third, c to the fourth. I rewrite it just so you can see the original problem. You do not have to rewrite it. Okay, so we look at 16 and 20, and what divides into both of those? 4. Now, our coefficients may not always have a common factor. They may not reduce. That's okay. All right, now, when we look at the a's, this is a squared over a to the 7th. So when I cancel 2 of those, it cancels with 2 down here and at least 5 in the denominator. We're left with an a to the 5th. Now, when you studied exponents, we talked about division could be rewritten as subtraction, and that would be a to the negative 5th. What does the negative tell us to do with that? Move it to the denominator. So I wouldn't rewrite it in terms of negative exponents. I would just put it where it belongs to start with. Okay? So a squared over a to the 7th. 2 of these cancel with 2 of those, and it leaves us a to the 5th. Okay, b to the third over b squared. So 2 b's cancel with 2 of those, and it just leaves 1. And then c to the fourth over c squared. 2 of these c's cancel with 2 of those, and it leaves 2. So this simplifies to 4, and then we have a b left in the numerator and a c squared over, in the denominator, we have a 5 and then an a to the 5th. And that is our simplified rational expression. Okay, any questions? So this is exactly what we do when we have a rational expression that consists of a monomial over a monomial. Now, what happens when we do not have monomials, like example 4. Let's see, we have 2 x plus 6 over 4x plus 12. Okay, I cannot cancel right now, because right now it is not written as a product. The numerator is written as a sum. The denominator is also written as a sum. And I can only cancel when it's written as a product. So, if I'm trying to simplify a rational expression and it's a sum or difference, the first thing I have to look for is, does it factor?
Yes.
Yes. Both the numerator and denominator do. They just have GCFs. 2. And it leaves x plus what? 3. And then what factors out of the denominator? 4. And it leaves x plus 3. Okay, so now it is written as a product. And when it's written as a product, we can cancel. And because we have matching binomials, x plus 3 in the numerator, x plus 3 in the denominator, this binomial cancels with that binomial. Okay, and what we're left with is 2 over 4, which reduces to 1/2. Okay, so when it's not a monomial, we have to factor so that we can write it as a product before we can cancel. If it doesn't factor, then it doesn't simplify. All right, example 5. All right, we have x squared plus 9x plus 20 over 2x plus 8.
Wait, if it does not factor?
If it does not factor, it does not simplify. This one does factor. Okay, so what can you multiply to get 20 that you can add to get 9? Very good, 5 and 4. So it's x plus 5 times x plus 4. So that's how the numerator factors.
Dude, that's not about
Okay, now the denominator just has a GCF.
2.
That's right. And when we factor out the 2, what are we left with?
X plus 4.
X plus 4. So now we have the numerator written as a product, the denominator written as a product, and both of these products have a common factor. We have x plus 4, and they will cancel. So that leaves us with x plus 5 over 2. Now, even if this were like x plus 6, I couldn't simplify anymore, because this can't be written as a product. This is just a sum. You can't factor further. So we're all done. So don't do crazy stuff like this. This is not equal to this. You can't do that. All right, let's make it go away and pretend like we didn't even see it. Number 6. All right, I want you to try this one. So this is a you try. All right, currently it is not written as a product, so we don't have common factors. So you gotta factor first to see if it'll simplify.
Shelby did it.
Okay. I did it. There. Okay, so the numerator has GCF of 6, and it leaves us the x plus 4. And then the denominator does factor to x plus 4 times x plus 3. So we do have a common factor of x plus 4. So we can factor that out. And this simplifies to 6 over x plus 3. Now, can I cancel the 6 and the 3? No. It is no longer written as a product, so we cannot. All right, here's your last you try. And when you get this one, you come up and you check my answer key and you pick up your homework. And if you have questions, you let me know. Wow. Here.